Hello, this is Mr. Stansbury. I'm going to take you through some of the problems on the 15A assignment. Okay, first one, number one, which of the following appear to be normal distribution curves? So for it to be a normal distribution curve, it's got to be like a perfect little bell curve. So this one here you can tell is kind of slanted. It's a little bit less of a curve here, and it's a little bit more steep. Sorry, slope. It's a little bit less here, and it's a little bit more here. So that one is not. But B is a nice, like, think of it like having a nice little line of reflection right down the middle of it. Okay, if you did a line of reflection down the middle of this one here, this is much bigger over here than it is over there, so that's not. Okay, this one does have the line of reflection, but a normal distribution curve, it's just got one big hump in the middle. Okay, so that one is not either. This one looks like it's got a nice little mirror reflection there, so D works. E is a little bit skewed to the right, so that doesn't work. And F, even though it's nice and flat, still a nice little perfect mirror image there. Okay. Number two, explain why it's likely that the following variables will be normally distributed. Okay, the diameter of wooden rods cut using a lathe. Why would this the following variable be normally distributed? Because they're, pretty much like the diameters are going to be affected by possibly the steadiness of the woodworker's hand, the operating speed. None of those are going to necessarily make like an overabundance of big ones or little ones. Okay, like again, the distribution of those should be, depending on how accurate they are, should be pretty close to, there should be about the same amount of a little bit too big as a little bit too small lathes. Okay, and then for C, amount of time a student takes to walk to school each day, there should be kind of an average amount, and then maybe they're walking a little bit slower one day, a little bit faster another day, but they could be affected by possibly by the weather. That would probably be the biggest thing you could think of. Possibly traffic, but I guess overall that probably would be a normally distributed curve for the most part. Okay, but again, weather conditions, especially if you've got like a whole bunch of snow for a while, that's going to definitely throw it off a little bit. But anyway, for the most part, it should be pretty close to normally distributed. All right, number three, discuss whether the following variables are likely to be normally distributed. Sketch a graph to illustrate the possible distributions of each variable. Ages of people at a football match. Now, probably not going to have a lot of young babies, and you're probably not going to have a lot of older folks. It's probably going to be a little bit more in the young crowd. So really, I probably think that the distribution would look more, possibly like this. Again, a lot more younger folks. And then, there'll still be some older folks there, but it's probably going to kind of slide off like that. That would be my guess. Okay. For B, distances recorded by a long jumper. Again, they're going to try to get their farthest each time, but, sometimes they might get a little bit more. Sometimes they might get a little bit less. But again, unless there's a significant amount of wind or rain or whatever, this should be pretty normally distributed. Okay, so I would choose that one probably would be. Numbers drawn in a lottery. Now, the numbers drawn in a lottery should be pretty, you're not going to necessarily draw all the numbers in the middle more than you would on the end. It should be a pretty flat graph, right? Like all the numbers, 1 to say 40, if all those numbers are in the lottery, they should all have an equally likely amount of probability of them happening. So that'd be a nice straight line. Would not be a normal distribution. And then the lengths of carrots in a supermarket, I would imagine that would probably be a little bit more like this one here. Oops, that would be D. There we go. So that should be more of a normal distribution, right? In fact, that would probably be a little bit more drawn out and a little bit more flat, because you're probably going to get some really, some really long ones and some little ones depending. Okay, so the B and D probably are more normally distributed than the other ones. Match each pair of parameters with the correct normal distribution curve. Okay, so This, remember this little mu here, that is the mean. And then a little O with the cape, sigma, I believe that is the standard deviation, okay? Okay, so the higher the mean, that's going to be, this is always going to be the middle number, okay? So 5 and 5, 15 and 15. So A, so this one here, A and C are going to be with these two over here. Okay, so that's going to be these two over here. And then the bigger the standard deviation, the more spread out the data is. So this one here I would say would go towards B, right? Whereas the one with the smaller standard deviation is going to be more of a tall, narrow spread. Like it's going to be a lot closer to the mean right there. So that should be A, okay? And then these two over here, C and D, those are the two that are, like, those are obviously have the bigger mean. And again, the one with the smaller standard deviation is going to be D. The one with the bigger standard deviation should be C. So there's the one with the bigger standard deviation. This one should be C. And D is the one with the really small. Look how tight that bell curve is. So that one is definitely going to be D. Okay. All right, let's take a look at 2. Sketch the following normal distributions on the same set of axes. So what we want to do is, let's get our first thing I want to do is make sure we get our means all in there. So let's just draw ourselves a nice long graph, give ourselves some space here. So let's see, 30 is only 2, so let's do, I don't know, we can do, say, 10, 20, 30, 40. Okay, so let's do A. A is at 25, so A is going to be, the mean is going to be right here, and the standard deviation is 5, so that's going to be, so we'll do A in green. Okay, so 25 right here in the middle, and the standard deviation is 5, so this should be kind of like a medium shaped bell curve. This is going to be a little tricky to do, so kind of like that. You can hopefully kind of understand how that's roughly going to be that. 30, let's do that one. B is, the mean is at 30, but now the standard deviation is only 2, so this one's going to be a lot taller and more narrow, right? Because the standard deviation is smaller. So that would be B, roughly. And then C is, mean is at 21 right here, and then the standard deviation is 10. That's a really big standard deviation, so this is going to have a really big, really wide, really flat mountain, so to speak, right here at 21. Okay, so this one would be C. Okay. All right, last one to take a look at here is 3. Consider the distribution curve here where where the mean is 4 and standard deviation is 3 shown. So here's our mean. Standard deviation is 3 because you're adding 3, subtracting 3 from the mean. That makes sense. Copy the above graph, and on the same set of axes, sketch the distribution for these two things here. So we got to know what that notation means. Okay, so for A, we'll do A in red here. So the mean, we're going to add 2 to that. So the mean is 4. Now the mean is going to be add 2 to that. So it's going to be about right here at 6. Okay, so there's going to be our new mean. And then the standard deviation is going to be the same. So basically this whole graph is just going to get shifted over 2 spots to the right. Okay, so it should kind of follow the other one as best we can. But again, it's just basically the mean is just adding 2 to it, and the standard deviation stays the same. Okay, now with C, our standard deviation again, our mean moved over 2, but now our standard deviation is 2 times that. So that means that our standard, since this is going to be a bigger number because it's, instead of 1 squared, it's going to be 2 squared. So that means the data is going to be spread out a lot farther. So it's still going to be right here at the mean plus 2 right here at 6, but now the data is going to be a lot more spread out. Oops, that was not a good one. So like so, and like so. Okay, so that would be C. Okay. All right, that's all we have for the 15A problems. If you have any further questions about any of this or anything else, please feel free to ask. Thanks.